March 6, 2016. You're looking back on January the 20th, 2016 of this year at the listings for the recent and upcoming Earth asteroid encounters. Now, NASA had 2013 TX-68 listed as coming in on March 5th at 1.3 lunar distances and that's 1 LD, guys, is the distance between the moon and the Earth, so just a little over that distance. Now, we were looking at the numbers and saying something didn't look right, so let's go up to February the 6th of this year. They had changed that from 1.3 LD to 0.044 LD to about 11,000 miles. The size had changed from 38 meters to 30 meters. Now, let's go back to today. They've got it listed coming in March 8th, back up to 38 meters, but 13 lunar distances is the missed distance. And that goes back to the furthest data that we've always had. The close approach, the minimum approach, and the furthest approach. So they've switched from the minimum to the closest to the furthest. The important part of this chart, guys, is it's showing just what we talked about. In the top, in the different colors, is this cluster or group that we were concerned with was coming in with TX-68. Look at that. And all of these are discovered on the day or the day before that they arrived. Look at the missed distances, 1 LD. Go down to 0.5 or half LD. Then on March 4th, 2016, EL1 or L1, 0.6 LD. March 5th, yesterday, 2 came by. These are all newly discovered. Another new one, EW1, coming by tomorrow at 10.8 LD, 39 meters, a little larger than we're looking at, but its minimum distance is nowhere near what TX-68 is still listed at 0.0002 AU, which is 11,000 miles. Now, let's look at 2016 EW1 that's coming by tomorrow, just to give you an example of what 11 LD looks like. I'm going to pull it around and give you a good idea because you've seen this JPL for TX-68 many times. But notice in the left, the outer dot is the asteroid EW1. The inner dot is Earth. You just can't see it because of the text is overlaid upon one another. But you see that distance? And notice in the bottom right, March 6th. Let's pull this up. You got 2 objects, middle left, today's date. 0.0311 AU. Now, this is the one coming by tomorrow. And even as we go through March 7th, we'll go through March 8th, through the 9th, you'll see that they keep that separation. They do not get closer. And they just spotted it. And so they know the data arc span. They know the information on it. Well, they've changed the information 3 times back and forth with TX-68. But they have not changed this model. It's still showing it right beside the planet. And it's still showing the distance at 11,000 miles as far as minimum. Now, why would they go from center to minimum to maximum? It's called confusion. They were confused, or either they're trying to confuse the people that are trying to keep track of this. But again, one of the important parts of this video is all the new asteroids that are suddenly appearing either a day before they come or the day afterwards. Look at this. It's listed as a discovery date on 2016-3-3. You see that? 3 days ago. They watched it for 3 days, and so they know where it's at. You look at the close approach data for this one, again, coming by tomorrow. Come down to, we'll scroll it to 2016, March 7th, at the very bottom of the screen. Nominal distance, minimum distance, and maximum distance are all the same. But 0.02, not 0.0002, like TX-68, but 0.02 all the way across. They see it, they know where it's at. Now, what they've done, the reason they say they're going back to 13 LD is one of the scientists at the Eurospace Agency thinks that an object that he saw matches the TX-68 as far as its orbit. And so they think it's going to be further away now. If they match, they have not changed the data, though. And it seems to be confusion. I don't know where it's from or why. But TX68, remember, it went from 3-day span to 10-day span going backwards. Condition code is still 8, very highly uncertain. They have not changed this. And you notice the solution date was February 25th. But if you look at 2016, March the 8th, they've updated this part. Went from the 5th to your nominal at 0.033, but right here, the minimum distance, not 0.02, 0.0002 AU. AU is an astronomical unit, the distance between the Earth and the Sun. So some units use LD, some use AU, but it's easily convertible. Notice that the time in that section was still 2 days and 6 minutes as far as the time of uncertainty. But the message in this video is not only how they're changing TX68, which I now call the Babylon asteroid because that word means confusion, but all of the new asteroids that seem to be appearing as this thing approaches. I think, and it's not only I that am saying this, that TX68 may not be alone, and that could be part of the confusion. You're tracking multiple objects that are going around the sun, coming in and out of view, and are they sometimes locating on a different object and they're not sure if it's the same one because they're very similar in orbit. Look how close to the ecliptic EL1 is, a different asteroid. But all of these are coming in these past few days. And when you see them, when they talk about one coming in, it's 38 meters, 39 meters. They have 1 day, or I've even seen it, guys, where they picked up radar imaging the day after it went by. When it's time for one of these to hit, just as in Russia a couple of years ago, there is no warning. It doesn't have to be a warning, either for two reasons. One is they're tracking it. They don't want to panic the public, or they're just coming out of nowhere, again, from the glare of the sun on these highly flat ecliptic plains, and they're hard to see. But at any moment, one of these could strike our planet. I'm not saying that TX68 will. I never have. All I've said was those numbers were incredible since day one, and they've changed them each time we narrowed it down. We're watching this. We're going to have a CERN update because they're getting ready to crank back up, and they have some important information coming out. It's a heads up. Be safe.